This is where it starts getting exciting. We're talking about a different way of measuring an angle called radians. Here in the book they explain kind of why radians are important, because degrees, well, it has no relationship to the actual measurement of any of the sides of the angle or to the corresponding side or anything like that. But radians provides a solution to this, because what a radian is, it's a way of measuring our angle where a radian, theta equals s over t, where s is the measure of the intercepted arc and r is the radius of the circle that we've created. So remember, we've got our initial side, we've got our terminating side. The direction's definitely going to matter. And so if we know the length of our intercepted arc and we know the direction of our radius, well, that is one way we can find a radian. But just knowing this definition here will certainly pay off for us. Now, to convert between degrees and radians, it's actually pretty simple, okay? Because if we think about it in terms of a circle, all right, it really does condense down pretty well. Half of a circle, if we have that half of a circle, that's 180 degrees. But also half of a circle, if our radius is 1, well, half of a circle has a circumference of pi. So knowing this relationship here, knowing that half of a circle, if our radius is 1, the semicircle right there would be pi, a length of pi, but at the same time it's 180 degrees. Well, that gives us all the information we need in order to convert between radians and degrees. To convert a degree measure into radians, we multiply pi radians for every 180 degrees. And it's the opposite to convert back to degrees, 180 degrees for every pi radians. So here we have 120 degrees. We want to change anything from degrees to radians. So we want to multiply this by something. We'll think we want to get rid of degrees, so I want to put the degrees on the bottom. I want to put the 180 degrees on the bottom, the pi radians on the top. I'm going to abbreviate radians with rad. 120 over 80 reduces to give us 2/3. So we have 2/3 pi radians. We've just converted 120 degrees to radians. It was that simple. Negative 45 degrees, the negative does matter. Well, again, we want to multiply this with 180 degrees on the bottom, pi radians on the top. Negative 45 over 180, that's definitely a negative answer. 45 over 180 gives me 1/4, and I still have that pi sitting up there. My units are radians. Of course, I can reduce that. I can make it look a little bit simpler, just making it a negative pi over 4 radians, and I would do that. Now here we want to convert these from radians into degrees. And so we have 5 pi over 6 radians. We want to change this to degrees. Well, since we're in radians, I know I want to put radians on the bottom. So pi radians on the bottom. On the top, of course, I put 180 degrees. Well, the radians cancel out. The pi's cancel out. 5 over 6 times 180. 5/6 of 180 is 150 degrees. Negative 3 pi over 2, that's negative 3 pi over 2 radians. So when I go to set up what I'm going to multiply this by. I know radians are on the bottom. If I had radians, I need to undo the radians by dividing by them. 180 degrees for every pi radians. The radians cancel out, the pi's cancel out. 3 over 2 times 180. Well, 180 divided by 2, of course, is 90 times 3. We have a negative 270 degrees. Don't forget the negative. Remember, that's telling us if our angle is going to be going counterclockwise or clockwise. And because it's negative, it is going counterclockwise from our initial side.